What if one small adjustment inside Tesla's factory quietly changed the future of the electric pickup market overnight? In late December, inside Gigafactory Texas, Tesla confirmed a subtle but critical update to the Cybertruck's production process, an update that may end up reshaping competition in the entire electric truck segment. According to Tesla engineers and industry observers, this change arrives at a moment when rivals are retreating, investors are watching closely, and the Cybertruck is no longer just a curiosity, but a strategic weapon. The timing matters. This update comes as Tesla's Cybertruck has just been recognized with a major safety award, earning the title of the safest pickup truck on the market, outperforming even long-established names like the Ford F-150. At the same time, Tesla now finds itself in a dramatically altered competitive landscape. Ford has decided to halt production of its fully electric F-150 Lightning, shifting its focus toward hybrid and extended-range electric models. That single decision removes Tesla's most direct rival in the American electric pickup segment. Tesla's Cybertruck has always been controversial. Since its launch in late 2023, it has divided public opinion with its sharp angles, raw stainless steel exterior, and radical engineering philosophy. But behind the bold design is a manufacturing approach that forces the entire auto industry to rethink how vehicles are built. Unlike traditional trucks built on stamped steel body structures, the Cybertruck uses an exoskeleton design. Its exterior shell is not just cosmetic, it is the primary load-bearing structure. At the heart of this approach is Tesla's use of ultra-hard 30X stainless steel. This cold-rolled alloy is extremely thick, incredibly strong, and almost impossible to shape using conventional automotive stamping techniques. Traditional presses and dies would wear out rapidly under such material stress. Tesla's answer was not to adapt old methods, but to abandon them altogether. Instead of stamping curves, Tesla designs the Cybertruck around flat planes and precise folds. Steel sheets are laser-cut, then bent at exact angles using controlled force. The process looks more like aerospace or architectural fabrication than traditional car manufacturing. Once formed, these panels are joined directly to massive aluminum structural components created through Tesla's gigacasting technology. These aluminum sections are produced using a 9,200-ton gigapress, one of the largest industrial casting machines in the world. Molten aluminum alloy is injected into giant steel molds under enormous pressure. Within seconds, near-finished structural components emerge, replacing hundreds of smaller welded parts. This reduces complexity, improves rigidity, and shortens production time even if the upfront investment is immense. Now Tesla has quietly refined this casting process. According to Wes Merrill, the Cybertruck's lead program engineer, a small but meaningful adjustment has been made to improve manufacturing efficiency. Tesla has not disclosed specific technical details, but internal testing reportedly shows no difference in crash performance or safety outcomes compared to earlier validated results. In other words, production is becoming more efficient without sacrificing quality. This matters because scale is everything. Tesla does not win by building a few impressive vehicles. It wins by building many of them quickly, consistently, and at lower long-term cost. With the Cybertruck now holding a safety crown and facing fewer competitors, even minor manufacturing gains could unlock a significant sales surge next year. And that raises a crucial question. Is this quiet factory tweaked the moment when the Cybertruck stops being experimental and starts becoming dominant? Because if Tesla has solved its scaling challenge just as competitors step back, the real impact may only be beginning. To understand why this latest Cybertruck update matters so much, it is necessary to step inside Tesla's factory logic and see how different this vehicle really is. The Cybertruck is not just another electric pickup with a battery swapped in. It represents a fundamental break from how trucks have been built for decades, and that break begins at the production line itself. Traditional pickups rely on a unibody or body-on-frame structure made from thin sheets of stamped steel or aluminum. These parts are pressed into complex curves welded together by the hundreds, then painted and assembled in long, multi-step processes. Tesla deliberately rejected this entire approach. With the Cybertruck, the company bet everything on an exoskeleton design, where the outer shell carries structural loads that would normally be handled by an internal frame. This decision immediately created a problem. The Cybertruck's exterior is made from ultra-hard 30X stainless steel, a material chosen for strength, durability, and corrosion resistance. However, That same hardness makes it nearly impossible to form using traditional stamping machines. Attempting to stamp such steel would destroy tooling's slow production and drive costs through the roof. For Tesla, there was only one option: reinvent the process. Rather than shaping curves, Tesla redesigned the vehicle itself. Flat surfaces, straight edges, and sharp folds are not just a design choice, they are a manufacturing solution. Large steel sheets are unrolled laser-cut with extreme precision, then folded at exact angles using controlled force. Every movement is calculated to minimize stress on the material and prevent surface damage, because stainless steel shows scratches far more easily than painted panels. This is where Tesla's automation advantage becomes critical. At Gigafactory Texas, robots handle most of the heavy lifting, from moving massive steel panels to positioning gigantic cast aluminum sections. Human intervention is limited not because workers are unnecessary, but because precision at this scale demands consistency that only automation can deliver. The backbone of this system is gigacasting. Using a 9,200-ton gigapress, Tesla produces enormous aluminum castings that replace dozens, sometimes hundreds, of smaller parts. These castings form key load-bearing sections like the floor structure and rear frame. The result is fewer welds, fewer alignment issues, and a structure that is both lighter and more rigid. The recent update confirmed by Tesla does not change this philosophy. Instead, it refines it. According to internal comments from the Cybertruck engineering team, the adjustment improves manufacturing efficiency within the casting process itself. That could mean faster cycle times, better material flow, reduced defect rates, or improved mold longevity. Tesla has not said which, and that silence is intentional. Manufacturing advantages are rarely shared publicly. What Tesla has made clear is what did not change. Safety standards remain identical. Crash test performance remains unchanged. Structural integrity is still validated against the same benchmarks that earned the Cybertruck its safety recognition. This is not a compromise, it is an optimization. And that distinction matters more than it may seem. In the automotive world, small efficiency gains can translate into massive cost reductions at scale. Shaving seconds off a casting cycle or reducing scrap rates by even a small percentage can mean thousands of additional vehicles per year. For a product as complex as the Cybertruck, those gains can determine whether demand is met or delayed. The real question now is not whether Tesla can build the Cybertruck. It already can. The question is whether Tesla has quietly crossed the threshold from experimental production to true mass scalability. If so, the competitive implications could be far bigger than most people expect, especially with rivals stepping away at exactly the wrong moment. While Tesla was refining the Cybertruck inside its factories, a much bigger change was unfolding outside the production line. In the American electric pickup market, Tesla's most serious competitor quietly stepped back. Ford's decision to discontinue production of the fully electric F-150 Lightning marked a turning point that few anticipated this early. For Tesla, the timing could not have been more consequential. For several years, the Ford F-150 Lightning represented the strongest alternative to the Cybertruck for buyers committed to a fully electric pickup. It carried a familiar name, a conventional design, and strong brand loyalty. Yet behind the scenes, the numbers were becoming increasingly difficult to justify. High production costs, battery supply pressures, and uncertain demand for large, fully electric trucks pushed Ford to reconsider its strategy. The result was a pivot away from pure electric toward hybrid and extended-range electric solutions. This move effectively reshapes the battlefield. With Ford stepping back, Tesla is no longer fighting head-to-head for dominance in the fully electric pickup segment in the United States. Other players exist, but none match Tesla's scale-charging ecosystem or manufacturing integration. That creates a rare opening, especially for fleet buyers and commercial customers who want to eliminate gasoline entirely rather than rely on backup engines. Industry analysts have noted that fleet operators, utility companies, and logistics firms often prioritize long-term operating costs over brand familiarity. For these buyers, a fully electric truck paired with a mature charging network can offer predictable energy costs, lower maintenance, and easier fleet management. With fewer competitors offering a pure electric option, the Cybertruck suddenly becomes one of the only viable choices at scale. This shift also changes how Tesla's recent manufacturing update should be interpreted. Improving efficiency is not just about margins, it is about readiness. If demand accelerates due to reduced competition, Tesla must be able to deliver. A production bottleneck at this stage would waste a strategic advantage that may not last forever. Tesla's internal testing has emphasized that the Cybertruck's safety and structural performance remain unchanged despite the production adjustment. That reassurance matters because fleet buyers are conservative by nature. They value reliability, compliance, and safety records more than radical design. Being named the safest pickup truck on the market is not just a marketing headline. It is a key credential when procurement decisions are made. There is also a psychological factor at play. When a major competitor exits a segment, it sends a signal whether intended or not. Some consumers interpret it as weakness in the technology. Others see it as an opportunity for the remaining player to lead unchallenged. Tesla appears ready to frame the narrative around confidence, stability, and long-term commitment to full electrification. However, this moment also carries risk. With fewer rivals to benchmark against, Tesla's execution will be scrutinized even more closely. Delivery timelines build quality, and real-world performance will define whether the Cybertruck becomes a mainstream success or remains a niche product. The market has shifted in Tesla's favor, but markets are unforgiving. The window is open yet not guaranteed. And as Tesla prepares for what could be its strongest Cybertruck sales year so far, one question hangs in the air. Can Tesla move fast enough to turn reduced competition into lasting dominance? Or will new challenges emerge before the advantage is secured? While the Cybertruck signals Tesla's push toward manufacturing scale and market dominance, another vehicle tells a very different story. One defined not by efficiency, but by ambition, patience, and unfulfilled promises. The Tesla Roadster has returned to the spotlight, and with it renewed questions about how far Tesla can truly go. When Tesla first unveiled the second-generation Roadster in November 2017, the announcement stunned the automotive world. Elon Musk described performance figures that sounded almost unreal. Acceleration from 0 to 60 miles per hour in under 2 seconds later hinted to be even faster. A range exceeding 600 miles, a top speed beyond 250 miles per hour, all at a starting price that undercut traditional hypercars by a wide margin. At the time, the message was clear. Tesla was not just building electric cars, it was attempting to redefine the limits of what was technically possible. Yet after the dramatic reveal, the Roadster slowly faded from view. Production targets slipped year after year as Tesla prioritized higher volume vehicles like the Model 3, Model Y, and later the Cybertruck. Skepticism grew, and many began to question whether the Roadster would ever arrive. Now, toward the end of this year, the Roadster has re-emerged. At Tesla's recent 2025 shareholder meeting, Musk announced that a production version of the Roadster would be unveiled on April 1, 2026. However, in a more recent public appearance, Musk reiterated that the car could still launch before the end of 2025. The conflicting timelines only add to the uncertainty. What is clear is that the Roadster of today is not the Roadster of 2017. Musk has stated that the upcoming version is a fundamentally different machine, which explains the new Roadster 2 designation. Yet Tesla has shared almost no concrete details about how the vehicle has evolved. No finalized specifications, no confirmed production volumes, no clear manufacturing roadmap. Behind-the-scenes signals suggest that development is still ongoing. Recent job listings indicate that Tesla is recruiting engineers to work on the Roadster's core architecture, implying that parts of the design remain in early stages. Musk has also acknowledged that production units would not arrive for at least 12 to 18 months after the unveiling event. For customers who placed deposits years ago, patience is wearing thin. For Tesla, the Roadster serves a unique purpose. It is not meant to sell in high volumes. It is a halo car, a statement of engineering confidence designed to elevate the entire brand. If Tesla succeeds, the Roadster becomes proof that electric vehicles can outperform the world's most exotic combustion engine supercars. If it fails, it risks reinforcing doubts about overpromising and underdelivering. There is also the question of credibility. Early buyers who committed significant sums to secure a production slot are watching closely. Invitations to unveiling events are symbolic gestures, but what they ultimately want is a car in their driveway. The Roadster represents Tesla at its most daring, but also its most vulnerable. And as anticipation builds once again, the stakes could not be higher. Because if Tesla cannot deliver its ultimate flagship after nearly a decade, the consequences may extend far beyond a single model. As attention shifts from hardware to software, Tesla's most ambitious project is no longer made of steel or aluminum, but of code. The company's robotaxi vision has once again moved to the center of investor focus, especially after Tesla's stock closed at an all-time high following recent developments. For Tesla, this is where future valuation lives or dies. At the start of the week, Tesla shares rose sharply, closing at just under $490, pushing the stock up more than 18% year-to-date and within striking distance of its previous record. Analysts widely attributed this surge to progress in Tesla's autonomous driving program, particularly in Austin, Texas, where the company has been quietly expanding its limited robotaxi operations. For months, Tesla tested autonomous ride-hailing vehicles with safety supervision. In Austin, safety staff initially sat in the passenger seat during city driving and moved to the driver's seat on highways. In the San Francisco Bay Area, a human monitor remained behind the wheel at all times. This cautious approach was designed to collect data, refine software, and avoid regulatory confrontation. That phase now appears to be changing. Over a recent weekend, multiple Tesla vehicles were observed driving on public streets in Austin, with no occupants inside, no safety driver, no passenger, just fully autonomous vehicles navigating real traffic conditions. For the first time, Tesla crossed a psychological and technical threshold that it has promised for more than a decade. The significance of this moment cannot be overstated. For years, Musk has told investors that Tesla vehicles would eventually operate as self-driving robotaxis, generating revenue while owners sleep. Skeptics dismissed the claims as unrealistic. Regulators remained cautious. Competitors pursued alternative sensor strategies involving LiDAR and high-definition maps. Tesla, by contrast, doubled down on a camera-based approach, powered by neural networks. Yet progress does not equal completion. Tesla has not announced when it will operate a fully commercial robotaxi service without safety supervisors. The regulatory landscape remains complex, fragmented, and unforgiving. Any high-profile incident could slow momentum overnight. The road to scale is long, and the margin for error is thin. This is why robotaxi is both Tesla's greatest opportunity and its greatest risk. Success would transform Tesla from a car manufacturer into a mobility platform, potentially unlocking revenue streams far beyond vehicle sales. Failure would not just hurt credibility, it would strike at the heart of Tesla's long-term narrative. For now, the evidence suggests Tesla is moving forward step by step under real-world conditions. But autonomy is not a switch that flips overnight. It is a process of accumulation, validation, and trust. And that leaves a critical question. Has Tesla finally entered the final phase of its autonomy journey, or is this just another milestone on a road that remains far longer than investors want to believe? While the Cybertruck captures headlines and the robotaxi fuels long-term dreams, Tesla's most decisive move may actually be its quietest one. The Model YL, a long-wheelbase, three-row version of Tesla's best-selling vehicle, represents a calculated shift toward practicality, volume, and stability. This is where Tesla's ambition meets everyday reality. The Model YL was first introduced in China, where demand for spacious family vehicles remains strong despite intense competition. Compared to the standard Model Y, this version is significantly longer, allowing Tesla to add a third row of seats and transform the vehicle into a true six-seat family SUV. This change targets buyers who need space, flexibility, and long driving range, but do not want to step into the premium pricing territory of larger electric SUVs. Despite its larger size, the Model YL remains surprisingly efficient. Its curb weight stays relatively low for a three-row electric vehicle, and the battery pack offers a range that remains highly competitive, even under stricter real-world testing standards. This balance between space and efficiency is not accidental. It reflects Tesla's growing focus on maximizing utility per dollar, rather than chasing extreme performance figures. Pricing is where the strategy becomes even clearer. In China, the Model YL is priced only modestly above the standard two-row version. If Tesla applies a similar pricing structure in the United States and other international markets, the Model YL could undercut rivals like the Kia EV9 or Hyundai Ioniq 9, while offering longer range and access to Tesla's charging network. That combination is difficult to challenge. Sales data already suggests strong acceptance. In recent months, the Model YL has accounted for a significant share of Tesla's Model Y sales in China, even at a higher price point than the base version. Delivery timelines stretching into the following year indicate sustained demand, not short-term hype. This is especially notable in a market where competition is fierce and price sensitivity is high. From a strategic perspective, the Model YL acts as a stabilizer. While experimental products carry risk family vehicles, generate consistent revenue, they appeal to repeat buyers, households, and fleet operators. They anchor Tesla's balance sheet while more ambitious projects mature. Taken together, Tesla's current lineup tells a clear story. The Cybertruck represents manufacturing reinvention. The Roadster symbolizes technological ambition. Robotaxi defines the long-term vision. And the Model YL delivers immediate scalable results. Tesla is no longer betting on a single breakthrough. It is spreading risk across products that serve very different purposes. The question now is not whether Tesla has ideas, but whether it can execute across all fronts at the same time. Because if it can, Tesla will not just shape the future of electric vehicles, it will define it. Tesla is standing at a rare crossroads. Manufacturing efficiency is improving. Competition in key segments is retreating. Autonomy is moving from promise to reality, and practical family-focused vehicles are driving steady demand. But which of these paths truly matters most? Is the Cybertruck the turning point that reshapes electric pickups? Is the Roadster worth the wait as Tesla's ultimate statement car? Will Robotaxi redefine transportation or remain an unfinished vision? Or is the Model YL the smartest move Tesla has made so far? Share your thoughts in the comments. Which Tesla model do you believe will have the biggest impact over the next few years? And why? If you found this breakdown valuable, consider subscribing for more in-depth, clear and timely analysis of the stories shaping the future of technology and transportation.